There are 3 investigations in section 8.2, and they start on page 429 in your textbook. You can just read the part in the textbook and do it on your own, or if you get stuck, you can listen to the descriptions that I do here. For investigation 1, you need to cut out a triangle and label its parts as shown. As you label the parts, since you're cutting it out, you should label the sides on the inside of the triangle. Otherwise, when you cut it out, you won't be able to see it anymore. Then you're supposed to make a copy of it and also label the copy that you have. When you're done, you should have 2 triangles that are the exact same size. Now we should arrange the triangles to form a figure for which you already have an area formula. We already have area formulas for rectangles and for parallelograms. For my triangles, I can't make it into a rectangle because I don't have any right angles. But if I turn that one over and put them together, I do get a parallelogram. And we know from before that the area of a parallelogram is base times height. But that parallelogram is not just the rectangle. The parallelogram is 2 triangles. So if I want the area of just one of the triangles, I'm going to do the area of the parallelogram, or base times height, and then I've got to split it in half because the triangle is only half of that big parallelogram. So the area of a triangle is given by the formula area equals base times height divided by 2, where A is the area, B is the length of the base, and H is the height. Another way to write that same formula is area equals 1/2 times base times height. Those two are equivalent. When you're writing that conjecture down, you should write a description of how you arrived at that formula and include an illustration. A good illustration to include is this one, how the parallelogram is made up of 2 triangles. So we're going to figure out the area of the parallelogram, which is base times height, and then we're going to divide it by 2 because it took 2 triangles to make that shape. For the second investigation, you're doing something very similar. You're going to make a trapezoid and then make a copy of the same trapezoid. Remember, as you're labeling it, label those on the inside of the shape so that when you cut it out, the labels are still there. Once you have them cut out, you should have 2 identical trapezoids, and you're supposed to arrange the 2 trapezoids to form a figure for which you already have an area formula. So now we know how to find the area of rectangles, we know how to figure out the area of parallelograms, and we know how to figure out the area of triangles. Sort of like with the triangles, if I take one of the trapezoids and turn it upside down, I can put the 2 together and they make one big parallelogram. So the area of each trapezoid is going to be the area of the parallelogram, but divided by 2 because it took 2 to make the shape. Now when I'm figuring out the area of this parallelogram, the area would be base times height. Now height is going to be there, but how long is this base? Well, it's the short base from the top, which was B2, plus the long base from the bottom, B1. So the area of the entire big shape of that parallelogram is base times height, and the base is really little base plus big base, base 1 plus base 2 times height. That formula gets us the area of the entire parallelogram, so if I only want the area of a trapezoid, I need to divide that by 2, because it took 2 trapezoids to make that shape. The area of a trapezoid is given by the formula area equals base 1 plus base 2 times height divided by 2, where A is the area, B1 and B2 are the lengths of the 2 bases, and h is the height of the trapezoid. Make sure when you write it down, you draw a picture and explain how we got that formula. The formula is related to the area of a parallelogram, but the base of that parallelogram isn't just b, it's made up of base 1 plus base 2. In the third investigation, we're going to find an area formula for a kite. And what we want to do is rearrange the kite into shapes for which you already have an area formula. Do you recall some properties of a kite? Create and carry out your own investigation to discover a formula for the area of a kite. Discuss your results with your group and state a conjecture. What I notice in this picture is that this triangle right here is exactly the same size as this triangle right there. And the same thing is true about this triangle and this triangle and the triangles on the bottom as well. So if I figured out the area of the whole big rectangle that they drew around the outside of the kite, I would be figuring out too much. There would be all of this blank area that I'm figuring out extra, but the kite would take up exactly half of that big rectangle. So if I could figure out the area of that big rectangle, I would just need to cut it in half or divide by 2, and that would be the area for the kite. Well, the area of a rectangle is base times height, and the base is the same as the length of this part of the kite, which is actually a diagonal for that kite. The height of the rectangle is the same as this length on the kite, which is the length of the other diagonal of the kite. So the area of that big rectangle would be diagonal 1 times diagonal 2. And since the kite is half of that rectangle, the area formula for the kite is diagonal 1 times diagonal 2 divided by 2. When you write that on your green sheet, make sure you draw a diagram to explain how you figured out the area for the kite and how it relates to an area formula that we already knew.